Hey everyone, welcome to this video. We're going to be covering absolute value linear functions and just absolute value in general within this outcome here. So we're going to cover a few different outcomes in this. Specifically, we're going to look at AN1 from grade 11, which is demonstrating an understanding of absolute value of real numbers. And we're going to be looking at RF2 from Pre-Calc 11, which is graphing and analyze absolute value functions. And we're just going to do that in the context of linear and quadratic. And we'll mention what some of the higher order functions look like when we actually get to those in the course. In your notes, you're going to find a link to the PDF of these notes and a link to supplementary notes in practice. I'd encourage you to look through those. So let's start out with what exactly an absolute value is. So absolute values are basically these types of parentheses, you can think of them, that will take whatever the value is inside and ensure that it's positive. So for instance, the absolute value of -7, this evaluates to +7, okay? Now, the important thing is when we're doing absolute values, we treat them like parentheses because we perform all the operations inside first, and then at the very end, if they're negative, that's when we flip them. So a common error when students are first starting out is to say, hey, this is going to be a plus sign now because absolute values are positive, 8 plus 3, but that's not the case. We want to go 8 minus 3. We still perform the operation, so we're going to get absolute value of 5. Oops, not -5, 5. Oh, geez, let's try that again. Absolute value of 5, and then the absolute value of 5 is just 5. Let's look at this one right here. We've got 2 minus 100, which is going to give us the absolute value of -98, and the absolute value of -98 is just 98. When we're talking about more complex operations, again, we're just going to treat it like parentheses. So I'm going to perform this operation first, then I'm going to flip whatever is inside to a positive, and then it's going to be 2 minus whatever that number is. So if I just come down here for a moment, this is going to be 2 minus the absolute value of -8, which in turn is literally just going to be 2 minus 8 or -6. So when absolute values are in a larger expression, we can certainly still end up with a negative. The important thing is that once we perform the operation inside the absolute value signs, like we did here, then it outputs to being a positive 8, but it still had that negative tacked on, that subtraction tacked on in front of it, which is why our final answer was a -6. So essentially, they're treated just like brackets in the larger operation, and we'll flip the sign if it's negative. So this link is going to direct you to some extra practice, just a little CUDA software worksheet with the answers. So please try that out and come find me if you're looking for help specifically with that stuff. We're just going to move on in this video, and we're going to also cover absolute value equations, which are pretty cool. So when we solve an absolute value equation, we're just going to start off like normal, and we're going to it's going to feel a little bit like a radical equation in the sense that I'm going to isolate the absolute value sign first. So for me, I would look at that and say, okay, I'm going to -2 to both sides. I'm going to get -5 absolute value, 5m minus 5 is equal to -75. And then I would divide by -5 on both sides. So I'm going to have the absolute value of 5m minus 5, absolute value. And then what's that going to be? 12 and 3 is 15, so positive 15. Now, this is where things are a little bit different. So I have to remember that the absolute value of a number always outputs to a positive. So this makes sense, first of all, in this case. The absolute value equals to a positive. So check, this is like a valid. If I had gotten a negative here, the question would actually be impossible. Because you can't have absolute values outputting to positive. But here I've got, an equation, absolute value signs, and it's equal to a positive number. So now what I need to do is I need to take into account that what's in the absolute value signs can either be what's there, it can be the positive root, if I want to think about it like a root, or it can be a negative root. So I have to do both cases. So either 5m minus 5 was just 15, or 5m minus 5 was -15, but because it was an absolute value signs, then it outputs to positive 15. And then I just treat this just like a grade 9 question here. So 5m is equal to 20, m is equal to 4, or 5m is equal to -10, m is equal to -2. And therefore, m has two solutions. 4, -2 are both solutions. And I don't need to check them in this case because it's just a linear absolute value. And If I did try to evaluate, let's say this was a negative 15 in this step here, and I try to check these numbers at the very end, then I would end up with an error. Actually, I wouldn't end up with an error. I would end up with you have to recognize at this point that it is impossible to achieve that negative 15. Anyways, yeah, so that's a fun little aside there. Let's do a couple more. So here, if you want to pause the video and try it yourself, but otherwise I'm just going to dive right in. So I'm going to subtract 4 from both sides, and we get the absolute value of 2 minus x absolute value is equal to negative 1. Ooh, this is not a possible thing. 2 minus x absolute value cannot equal to negative 1. So we can just say impossible here. It's outside the range of values that we can accept. And if I try to graph this, there's actually no solution to this graph. I will get into that in the next video. For this right here, what I'm going to do is I'm going to add 9 to both sides, add 9 to both sides. Then I'm going to get 6 onto 1 minus 5x. Of course, that's all absolute value, equals 67, 66. 66 divided by 6 is just going to give me 1 minus 5x. Absolute values is equal to 11. And then here, so I like that positive number there. And again, what I'm going to do is I'm just going to look at both roots. So I'll look at the positive root and I'll look at the negative root, because 1 minus 5x might have been 11, or 1 minus 5x might have been negative 11. I'm not sure which one it was. So I just solve it like normal. So I'll subtract 1 from both sides. So I'll get negative 5x is equal to 10, or x is equal to negative 2. And then I'll subtract 1 from both sides. Negative 5x is equal to negative 12. Divide by 5. X is equal to 12 fifths. And of course, we'll just leave it as a fraction. Let's just see what the next slide is. So these ones are just further, I'm not going to bother doing them in the video there. Please come find me in class if you're having trouble getting to the correct answer. And if not, I'll see you in the next video.